to this tutorial on how to find the mole ratio to solve stoichiometry problems. We'll go through the process step by step using a practical example. Step 1. Write the balanced chemical equation. This is crucial because the coefficients in the balanced equation tell us the mole ratios of the reactants and products. Let's consider the decomposition of mercury, 2 oxide, HGO. Step 2. If we're given the mass of a substance, we need to convert it to moles, using its molar mass. The formula for this conversion is moles equals mass in grams divided by molar mass in grams per mole. Step 3. Determine the mole ratios using the coefficients from the balanced equation. In our reaction, the mole ratio of HgO to Hg is 2 to 2, or 1 to 1. The mole ratio of HgO to O2 is 2 to 1, and the mole ratio of Hg to O2 is also 2 to 1. Step 4. Use the mole ratios to make calculations. Multiply the given number of moles by the appropriate mole ratio to find the unknown quantity in moles. For example, if we know the moles of HgO and want to find the moles of Hg, we would multiply the moles of HgO by the ratio of 2 moles of Hg to 2 moles of HgO. Step 5. If the problem asks for the mass, convert the moles back to mass using the molar mass. The formula for this is mass in grams equals moles times molar mass in grams per mole. Now let's work through an example problem. Calculate the mass of mercury produced when 5.00 grams of mercury, 2 oxide decompose. Step 1. We've already written the balanced equation. 2HgO solid yields 2Hg liquid plus O2 gas. Step 2. We need to convert the mass of HgO to moles. The molar mass of HgO is 216.59 grams per mole. So 5.00 grams divided by 216.59 grams per mole gives us 0.0231 moles of HgO. Step 3. We've already determined the mole ratios. We know that the ratio of HgO to Hg is 1 to 1. Step 4. Using this ratio, we can determine that the number of moles of Hg produced is equal to the number of moles of HgO that decomposed. So we also have 0.0231 moles of Hg. Finally, step 5, we need to convert the moles of Hg back to mass. The molar mass of Hg is 200.59 grams per mole. So 0.0231 moles times 200.59 grams per mole gives us approximately 4.64 grams of Hg. Therefore, when 5.00 grams of mercury, 2 oxide decomposes, approximately 4.64 grams of mercury is produced. This demonstrates how we can use mole ratios to solve stoichiometry problems.